And this is on page 255. And they give you no space underneath the question, but I guess you have space above the question and on the next page if you need. So projectile is launched upward with a speed of 50 meters per second, and they give us an equation, height in meters, modeled by this equation. And this equation is actually quite accurate given the situation for a couple of reasons. One, whatever's in front of the x squared, or the t squared in this situation, should always be half of gravity if you're doing a real life problem. And we got negative 4.9, and gravity is 9.8, so that is a reasonable number. Whatever is in front of the t, so some of you are taking physics, whatever's in front of the t will always be your initial velocity, which works out in this situation as well. So this model is actual. Sometimes in math textbooks, they make up questions and they don't actually match real life problems. This one does. The problem with a graph matching real life problems is the numbers aren't as nice. Like, oh, negative 4.9. So when I go to graph in part A, first of all, I think plugging in 0 and getting 10 for y is the easiest point. But after that, things get a little messy. Like, I could plug in 1, and if I plug in 1 for t, I'm going to get 50 plus 10 is 60 minus 4.9. I would get 1, 55.1, about. But again, that's not a very nice point. Now, it might make sense to you that if you had an object go up in the air, because of gravity, eventually it's going to hit its maximum and then come back down. What we're going to want to find, and we're going to use technology to do this, is we're going to want to find this vertex and maybe this x-intercept. So what we're going to do is we're going to go to our calculator. We're going to push y equals, and this is why you have a graphing calculator, because a graphing calculator allows you to graph. So what we're going to do is we're going to type in the negative 4.9. There's no t, but we can hit the x button right beside the alpha button. X squared plus 50x plus 10. And when I hit graph, something shows up. Now this doesn't look at all like my preliminary drawing. My preliminary drawing says it should be a parabola. Does it make sense that our parabola should be going down because of the negative 4.9? But my graph looks like a straight line. And the reason is because right now I'm technically only looking at a tiny bit of it. So another thing that we have to learn how to do things on our calculator is adjust the window so we see more of this. So what I'm going to do is I'm going to go to the window button right beside y equals, and it looks like I need to see more of the x's. So maybe I'll go up to 50, and it looks like I need to go higher. So my y max, and I already figured out 55.1, so it's going to go higher than 55.1. Maybe I'll go up to 100. So now I'm going to push graph again. It might be that I get lucky and this works out perfect. It might be I have to do this again. I hit graph. Okay. Looks like I went too far on my x. I didn't need to go that far, but not quite high enough on my y. Okay. Now, did you see how we started a table of values? I did 0 and 10. I did 1 and 55.1. And then I was like, this looks like it's going to be tedious because of the decimals. And I didn't want to do any more mental math after that one. Another nice thing about your graphing calculator is your graphing calculator, above the graph button says table. If you go to that table, it's done it for you. And that's kind of nice because I can see that around 5, it's at 137. That looks like close to the biggest, around 5. So for my window, for my window, first of all, I didn't need to go all the way to 50, so maybe I'll bring it back to 20. And my Y max looks like 150 is going to be enough. I can tell that from my table. Now when I hit graph, it's closer to what I have. Some other things you might notice. You notice how thick my y-axis is? Because currently on my window, this scale you can change. So I can make my y scale, if I'm going up to 150, I can make it go by 50s. Then there will be only 3 little dashes. 50, 100, 150. Can make it go by 10. Going by 1 was kind of useless at the beginning. It just made a thick line because it drew so many lines all the way up. So there's some information about your calculator. Now again, the nice thing about your graphing calculator, or if you're using the app Desmos at home, you can graph this. On Desmos, you can just click where the maximum is and it will pop up for you. On the graphing calculator, everything you want to find about this graph, you can do with the calculate button. So I go second, trace, because that's where it says calculate. This one has a maximum, so I hit number 4. It's really close to my maximum right there, but it says where you should be to the left side, so I'm going to use my arrow key, make sure I'm to the left, push enter, then make sure I'm to the right, and what you're doing is you're telling your calculator to find the maximum between those 2 points. Then it says guess, you just push enter again, and it tells you exactly that at 5.10, 137.55. You can label that now. 5.10. It takes just over 5 seconds to reach a maximum height of 137.55 meters. So, then it wants one, let's get this x-intercept. We can do that with calculating as well. So I go second, calculate. And remember all the words for x-intercepts. Zeros, roots, solutions, x-intercepts. So if I go to number 2, I can find an x-intercept. Again, it says go left and right. Now I'm already to the left of this x-intercept, so if I push enter right away, it's for sure to the left. Now I could use the arrow key, and you see how many times I'm going to have to hit it to get slowly over, or you can just type in a number. Like, I went up to 20. I'm pretty sure 18 is to the right of this one. If I type in 18, sure enough, there's 18. And now is my x-intercept between those 2 lines? It is. So when I push enter on the guess, it finds it exactly. Does it make sense that an x-intercept, so I've got 10.4, the y would be 0? 10.4, comma 0. Look on my calculator, though, how it wrote the 0. Negative 1 e to the minus 11. That e to the minus 11 is scientific notation. It means negative decimal 0.000000000000001. 11 zeros, well, the 1 will be the 11th digit. It's basically close to 1. What the calculator is doing, though, is it's trying to find this point by getting closer and closer and closer until it feels it is close enough. And apparently it felt close enough before getting there. Exactly. So, we've got our picture, we've labeled some points. We are now going to explain and identify the significance of different things. First of all, the y-intercept. Sometimes called the initial height. Does that make sense? At time 0, that would be our height. Next, our x-intercept. That's the 10.4. This is the time that the object takes to hit the ground. You shot it up in the air. It's up in the air for a long time, but gravity does its thing and brings it back down. Can you imagine a world where the gravity wasn't the same? And there'd be like some places where there'd be like no gravity. It'd be accidentally, if you're just tossing a ball up and down and catching, all of a sudden you hit the no gravity spot, the ball goes up there. That'd be weird. We can mess our world up with.
I mean, gravity does have different values depending on
Right.
It's not to that extent.
No. I mean, we did it to that crazy extent. We like, all of a sudden, just the Olympics, high jump, boom, the guy's gone. He just happened to jump right at the right spot. World record forever. Well, I guess you only get the record of what the bar is at, right? So if he jumped and went off to space, we never saw him again, he could have made such a better world record, but instead, he's just gone. He can't even compete anymore. Yeah. You have to use this negative for the beginning. So there's a difference between the subtraction sign and the negative sign. Yes, if you're having trouble graphing, sometimes the trouble that you have graphing is this initial sign has to be the negative sign beside the enter sign, not the subtract sign. For the calculator, those are totally different things. So if you're getting an error and don't know why, it might be that you use the subtract sign instead of the negative sign. Okay, so we've explained the significance of our y-intercept, of our x-intercept. The vertex in this case, since it opens down, the vertex will give us the maximum height and the time it takes to reach that height. So we knew that it was 5.1 seconds to reach that maximum height of 137. And finally, it asks us to talk about the domain and the range. Since this is a real life problem, okay? Normally the domain for a parabola is everything, because it goes on forever in both directions. In this situation, the only domain that makes sense is starting at 0, because the object isn't flying in negative time. It started when time was 0, and it only followed this path, right, until 10.4. I don't know if since I rounded, I'm going to put a round bracket there. Could be, if it was exact, I'd put a square bracket, but it hits the ground at 10.4. It doesn't keep going, right? It's not like it's like just burrows and keeps the parabola going into the ground, digging a hole as it goes. It will bounce or something like that. And same thing for our range. When it hits the ground, that's the lowest it goes is 0. And the highest it goes was 137.55. Is that right? Yes. I guess rounded, I don't know if I can use a square bracket or round bracket. It's a little bit awkward there. But the vertex is included, so normally we would include a square bracket to say that it includes. So that would be our domain and range, and the reason why we would have those values. All right. Circle question number 10.